This is aleatorium. It's a music box that you can script with Lua. Let's show this off just by walking through the code and uncommenting stuff so we can hear how it changes. So the API is pretty small. The parts of it that you need to worry about are this function tempo sync, which gets called back at 96 pulses per quarter note. We're running at 120 BPM right now. Reset parameters just sets all the voice parameters back to their default value. We have play note, which takes a channel 0 through 7 and then a MIDI note value, and then set param, which targets a channel, takes a parameter, and then a value. So because this tempo sync's running at 96 pulses per quarter note, we kind of need to slow it down. We're running at, I guess this would be 3/4 note, running 3/4 notes. We have a little countdown table for each channel. So let's switch it so that it gets a little bit more movement. We'll give each voice a different random timing as it's running, and then let's increase the number of voices. The other thing we're doing is we just have each voice playing a different octave. Instead, let's use a random lookup table for the notes themselves. And then let's also send the voices to reverb and delay randomly. We can also give the voices a little bit of a decay time difference based on which octave they are. So now the lower voices last longer. And then just to finish the song, let's add in a little percussion. I'll just copy paste this in, but this just uses one of the higher voices as a little simple sound. Once you're done with your song, you can just type save scripts and then my song.lua. Oops, what did we do there? My serial implementation isn't perfect. Let's add a few lines in here. Strange. When it does work, the idea is that we will have all of our songs on device. This is only 1,700 bytes. Each song can be 16K, and then there's 16 megabytes on the flash chip, so plenty of space for songs on the device. And then every time you press the button on the device, it loads up a different song. So here's the hardware itself. The box is this chanting machine that I got off the internet. It has a pretty hacked up top here, so you just turn it on and it starts playing one of the scripts that you had loaded up. This acts as a volume knob, but it's sending into a digital thing, so we could potentially make it so it is accessible from scripts eventually. And then if you just want to go to the next song, you press the button on top. The board looks like this. It's a simple RP2040 base board. Eric Bromba did the original design. I modified it a little bit. You could also, if you have something like this, a PyPico demo board, or even a little like I/S chip, the code should be pretty portable to those as well. I guess that's the whole video. Thanks for watching this far. If you have, all the code and hardware design files are on my GitHub, which I'll link. I guess I'll judge interest. If people want one, I can do a run of boards or maybe do kits or something. It's a pretty simple kit. Most of the assembly is done by JLC. I've even got the assembly files in the KiCad files. So yeah, you can get assembly done, and then there's just a few bits that need to get soldered on. I'm hoping that people port it to their RP2040 devices. It's pretty straightforward. Hopefully, you just swap out your I2S implementation and it just goes. And then the Lua could be extended with support for other inputs, but I wanted to keep it simple with just the one. And you don't really even have it. It's just a music box. Yeah, thanks for watching.